This video is about sketching a graph of a function based on information about its first and second derivatives. So here we're going to have a function of x called y. Y is a function of x, and we're going to be given information about the first derivative y prime and the second derivative y double prime. And in this type of problem, we're actually not given any particular numbers for the x's. We're going to be given points x1, x2, and x3 on the number line, and just making a graph based on that. Here we're going to assume that x1 is less than x2 and x2 is less than x3. Now we're going to suppose in this particular example that the first derivative is positive for all x, which means it's an increasing function. What's more complicated is the information we'll be given about the second derivative. First of all, we'll be told that at x1, x2, and x3, the second derivative is going to be 0. Also, we're told that the second derivative is positive when x is less than x1 and when x is bigger than x3. Finally, we're told that the second derivative is negative for x between x1 and x3, except of course at x2 we already know that it's 0. And we're asked to sketch the graph of the function y. Now that's a lot of information. So in order to make sense of it, we're going to use a little chart here. In particular, the information that we're given is mostly about the second derivative, so we'll only worry about the second derivative. The first derivative, what we know is it's positive and therefore it's an increasing function. The second derivative is what's got a lot of information about it. So here, what we first know is we have a number line. This will be the x number line. And the important values are x1, x2, and x3. And we know that x1 is less than x2 and x2 is less than x3. We also know that the second derivative is 0 at these points. So here, second derivative is 0. At x2, second derivative is 0. And at x3, the second derivative is 0. And then the second derivative is positive if x is less than x1. So here are all the points x that are less than x1. And so here we know that the second derivative is positive. Also, for x greater than x3, we know it's positive. So here's x bigger than x3. It's y double prime is positive here. For x between x1 and x3, y double prime is negative. So over here it's negative. It's actually 0 at x2, but it's also negative between x2 and x3. So between x1 and x3, it's negative with the exception of x2. So let's write that down here. Y double prime is negative, y double prime is negative. So I haven't done much except take this complicated information that was written out here and expressed it in a table, or a chart if you like. Now let's get to work on actually graphing the function f. So this is my x-axis, and again, I have x1 on the number line, the x number line, x2, x3. Now above and below this, I'd like to graph it. Well, the first thing I remember is what happens with the first derivative. Remember, we were told that the first derivative is positive. So that means that whatever we do, we have to always be drawing an increasing function. This function has to increase. The second derivative tells us about the concavity as we go along. So here we're told from left to right, if we look at this, we have the second derivative is positive. That means when we go work from left to right, up until x1, we must be concave up. But then after x1, the second derivative is negative, so it must be concave down. So we're concave up, and then we have to start turning down. We get to x2, and then we're still turning down because between x2 and x3, we're still concave down because the second derivative is negative. So we continue to turn down. But we have to keep going up. At x3, the second derivative changes and it becomes positive again. That means we turn up. Notice that this function's always increasing because the first derivative is positive. So we have to draw an increasing function. The information given in this chart tells us that for x1 and for x3, we have inflection points because that's where the concavity changes. We started with concave up, then we become concave down. These are inflection points. Now notice, finally, this point is not an inflection point. Even though the second derivative is 0 here, it's not an inflection point. Why? Because the second derivative didn't change sign. It was negative, and then it continued to be negative. It was concave down, it continued to be concave down, even though the second derivative was 0 here. The only time you have an inflection point is when the concavity changes from concave up to concave down, or from concave down to concave up.